All right, hi guys, welcome to part 4 of your Prep for Calc exam review videos. So we're going to start with question number 21 here. Find a formula for a quadratic function with vertex at -6, 1 and passing through the point -2, 8. Write your answer in vertex form. So first thing we need to make note of is vertex form, very important. So vertex form looks like f of x equals a x minus h squared plus k. And this is for your vertex being a point h comma k. So this is what your vertex is. And here we know that our vertex is -6, 1. So we can start writing the formula, plugging those in. So f of x equals, we don't know what a is. We write our x. We know that h is going to be -6. And then that'll be squared. And then we plus our k, which is the y component of our vertex. So plus 1. And now we also know that this formula needs to include the point -2, 8. So since 8 is our y value, or our f of x, we know that f of -2 is 8. So we're going to put in our 8 right here. We still don't know a. We know that our x is going to be -2. So we'll have -2 plus 6 in here squared, because the negatives in minus -6 come together to create a positive. Then we have our plus 1. With this, we can solve for our a. So let's see here. We have 8 equals a. 6 minus 2 is 4, and 4 squared is 16, so a times 16 plus 1. And then from there, we'll have 16a, and I did flip the sides right there. So 16a, and then on the other side will be 7. So I subtracted the 1 out of the 8, and then divide that 16 away from the a, and we get a equals 7/16. So all in all, our solution for question number 21 is f of x. Now we know what our a is. That was our missing variable in our equation before. If we look back and notice, we don't know a, but otherwise that would be an acceptable formula. So that's what we found here. So f of x equals 7/16 x plus 6 squared plus 1. And that is your solution for that problem. So now I'm going to continue into the next question, number 22. Convert the quadratic function f of x equals 3x squared minus 24x plus 43 to vertex form by completing the square. Then we need to identify the vertex, the axis of symmetry, and sketch a graph of the function. So first of all, we know from the previous problem, the format that we are looking for is that top formula that I'm going to box in blue, or circle in blue. It's very important. This is our vertex form. So we need to convert it by completing the square. So the first thing we notice when we look at this formula is that there is a 3 here. So we're going to need to move this 3 out of the equation first. Well, not out, but we're going to factor it away from the rest of it. So we have 3. That leaves us with x squared minus 8x plus 43 thirds. Right? So if we multiply the 3 back in, we would get our original function up there. And so from here, we're going to perform completing the square on the stuff that is in parentheses. So the important stuff that we want to pay the most attention to right now is this x squared minus 8x. So if we take that x squared minus 8x, what would we have to have here in order to make it a perfect square? So for x squared minus 8x, if we divide -8 by 2, we get -4. So we're trying to figure out what would make x minus 4 squared. So if we FOIL this out, we end up with x squared minus 4x plus 16, right? And that's x squared minus 8x plus 16. So we want to have a 16 on the end there. Now that we know what we want our perfect square part of the vertex formula to be, we can go back to our function over here, f of x equals 3x squared minus 8x, and now here's where we add in what we were just looking at. So if we add 16 and we subtract 16, we haven't actually changed any of the values in the formula because those two would technically cancel out. However, we are about to use it for completing the square. So now I'm going to rewrite this. And the difference between this, what I'm writing right now, and what I had before, is we're going to have just the perfect square in here, so plus 16. Now, the rest of these things, I'm going to underline in green here, these pieces we're going to bring out of the parentheses. We have to multiply them by 3 to bring them out. So we're going to have minus 48 plus 43 on the outside of the parentheses. Now we notice that x squared minus 8x plus 16, that's our perfect square. So that is the same as x minus 4 squared. So now we've rewritten that as 3 times x minus 4 squared. And then we'll take those two numbers at the end, the negative 48 and positive 43, and we will stick them together. And we will have minus 5. Okay, and now this is in vertex form. And in the vertex form, we know that it is a times x minus h squared plus k, and the vertex is h comma k. So we have x minus 4 here, so our h is a 4, which means that our vertex has an x value of 4. And then we have a minus 5 on the outside, but we have a plus k, so that means our k must be a negative 5 in order to create that minus out there. So this is our vertex. And since we know where the vertex is, quadratic functions look like either a U or a mountain, and they're symmetrical about the vertex. So if we imagine, see, we're going to sketch a graph of the function. And so here are a pair of axes that we can use. And so if our vertex is at x equals 4 and y is negative 5, our vertex might be about like somewhere like here. So that's going to be our negative 5, this is 4. And then since we know that we have a positive x squared term at the front, we know that the end behavior of the function is going to point up. So we might have something that looks kind of like this. And it says sketch, not graph, so it doesn't have to be perfect. So we'll see that our axis of symmetry will go right down the middle, right along 4. So our axis of symmetry can be described by x equals 4. And that is the equation of our axis of symmetry. So now we have our vertex, we have our vertex form of the function, and we also have our axis of symmetry and the graph sketch. And that completes question 22. So now we're going to move on to the next page here, onto question 23. So an apple is thrown vertically into the air. Its height h in feet above the ground at time t in seconds is given by h of t equals negative 16t squared plus 48t. So part A says, find t when h of t equals 0. Okay, so we're going to go ahead and write out what would h of t equals 0 look like. So h of t is negative 16t squared plus 48t. That's h of t. And we want to find out what t makes it equal 0. So let's go ahead, and it looks like both of these terms have a t in them. So maybe we factor out a t. So we have t times negative 16t plus 48. And that is a t, not a plus sign. And that is still equal to 0. So what values of t would make this whole expression equal 0? Well, first we see that t on the outside. If that t on the outside equals 0, then the whole thing is multiplied by 0, and it is just 0. Now with this inside function, if that part was equal to 0, then the whole thing would also be equal to 0 since it's multiplied. So we're going to set that negative 16t plus, make that t a little taller, plus 48 equal to 0. Negative 16t equals negative 48, and our t equals 3 if we divide that negative 16 over. So when h of t equals 0, t is 0 or 3. And so notice that it has the first time ht equals 0 and the second time. So if an apple is being thrown in the air, we can kind of imagine it on a graph that might look like this, where we have the height of the apple above the ground, h, and the time in seconds on the horizontal axis. So when the apple is first at h of t equals 0, it's right here, right? Because h of t equals 0, this is the 0 level, right? And here's our function. I'm going to highlight that in red. There we go. So the first time h of t equals 0, the apple is leaving the ground. So let me write that in blue. Apple is leaving ground. Okay, and now at the second spot over here, if the apple went up, it must come down, right? So this is where the apple hits the ground again. So we found our t values, t equals 0 and t equals 3. That's 0, that's 3. And then we also found what is happening to the apple for both times. So on to part B, we need to know what the maximum height that the apple reaches is. So that height might be, and I'm in yellow right now, that height would be up here, right? So we want to know what that maximum height is up at the top. I'm drawing on the little graph up in the first part. Now when we think about a quadratic function, it's symmetrical, right? So straight up and down the middle, halfway between 0 and 3 is where this maximum point would be. So let's find that middle point. We know 0 and 3. Halfway between 0 and 3 is 1.5. So t equals 1.5 is the time when the apple will reach the maximum height. And the maximum height that the apple will reach will be the same as h of 1.5, right, if we use function notation. So let's plug 1.5 into our h equation. Plus 48 times 1.5. And if I plug this into my calculator, I get h of 1.5 equals 36. So the maximum height that the apple reaches is 36 feet. So 36 feet, and the unit for the time is in seconds. Don't forget your units, guys. Number doesn't mean anything without a unit. So let's move on to question 24. Suppose a quadratic function has the following properties. What are the domain and range for this function? So we know that it has zeros at x minus 2 and x equals 8. And we know that it has a vertex at 3, 12.5. So let's think about what this graph might look like. So if I draw a coordinate plane, let's say maybe negative 2 is about here, and 8 might be about here. And our vertex is at 3, 12.5, so it'll be somewhere up here, right? Now, we know that it has two zeros, and we know that it's a quadratic function, and quadratic functions make a parabola shape. And if this is the vertex up here, like it tells us, it's going to look something like this. Now it wants to know the domain and range for this function. So when we talk about domain means all of the x values that work in a function, that don't make it go undefined or create imaginary solutions. So here we have the arrows on this graph going down and to the left and down and to the right. And with a quadratic function, those will keep going on forever. There's no weird square roots or dividing by things that could end up being zero to worry about. So here our domain is perfectly fine to be negative infinity to positive infinity, and you don't have to write the plus with the positive infinity. I was just doing it for clarification's sake. Now our range, those arrows, like I said, are going to keep going on down forever, right? But what's the highest? Okay, well, let me start that down forever part. Our lowest y values are going to go all the way down to negative infinity. But our highest y value, that would be the y value of the vertex, which is 12.5. Okay, so moving on to question 25, which of the following are possible equations for the parabola shown? And so the first thing that I see here is that all of these equations have negatives, and we know that our parabola is upside down, and having a negative that's going to end up in front of the x squared is going to mean an upside down parabola. So we don't have any that are going to end up being right side up parabola equations. So that part is good. And so if we keep looking at our equations here, we notice that B, C, and D are all in somewhat that vertex form. We can imagine that there's a plus 0 there. So if we look at it here, P is a y value since it's up on the y-axis. Q and R are x values. And so our vertex is P. It's at x equals 0 and P, right? That's what our vertex should be. And so, we can actually look at this first one here. We can imagine that this is x minus 0 squared plus P, right? And that would fit our vertex form. We have 0 as our x and P as our y on our vertex point. So A could actually be a possible formula for it. Now if we look at B, P is not an x value, right? It's not P comma 0, it's 0 comma P. So this one would be not correct. Now if we look at C, Q is an x value, so that's okay. We have x minus Q squared plus R. The only thing is that this is still in vertex form, right? So based on this, our vertex would be at Q comma R, right? And that is very clearly not true. If we look at our graph here, our vertex is at 0 comma P, not Q comma R, so that one doesn't work. Now if we look at D, very similar story, except instead of a positive Q, we have a negative Q. Negative QR would be our vertex, and that's not correct according to the graph, so D is eliminated as well. Now if we look at E, the formula here in E is two binomials multiplied together, right? And so when we have two binomials multiplied together, if one of those is equal to 0, the whole thing is equal to 0, right? So if we say, what happens when x minus q equals 0? X is equal to q, right? And then same thing here, x minus r equals 0, x equals r. So these are actually our zeros of the function. Right here is what we've got going on in that part E. And so because we have these two binomials that are based on the zeros of the function multiplied together, and then we have the negative out front to make it an upside down parabola, we can actually include E as a possible solution as well. So for question 25, Options A and B are possible equations for the parabola shown. All right, moving on to page 3 here. We need to find each of the following for the graph of f that we see over here on the right. We need f of b first. So let's see, what is f of b? Well, we know that this is similar to f of x, right? The thing in parentheses in the functional notation is your x value. And so if we look at our x value b, the point that has an x value of b along the graph of f has a y value of r, and that is what we want here. All right, now on to part B here. Solve f of x equals r. So this is asking what value of x would give us a y value of r. So if we look at our y value of r over on the graph right here, we see that it intersects the graph at 2 points. So we actually have 2 x values that would make this possible. So here, our answers are B and D. X equals B and D. All right, so on to the next one. I'm going to switch my color to red this time. Solve f of x equals 0. So if we're looking at this graph over here, is there any point where the graph of f, that parabolic line that we've got going on, is there any time when that equals 0, when there's a y value of 0? And the answer to that question is no, because it stays above that x-axis the whole time. And because of that, this one here has no solution. All right, so on to part D. I'm in yellow this time. Find the intervals on which f is increasing. So when a function is increasing, we're looking for a positive slope from left to right. So if we go from left to right, we're going down this way, right? So that's a decreasing slope. Not quite what we want. But as soon as we get down here to C, right after C, we see, that was funny. Right after point C, we can notice that the graph starts to go up from left to right, which means the graph is increasing. And that starts at point C, and it keeps on going all the way off into infinity. So by looking at the graph, we found that the graph is increasing from C to positive infinity. All right, moving on to part E. Let me reposition here a little bit. Is the average rate of change from x equals A to x equals B positive, negative, or 0? Okay, so I'm going to go ahead and erase some of the lines that I have going on the graph over here, just to make it a little bit easier to see what we're doing for this part. I think I got most of it. So if we're looking at average rate of change between 2 points, we can kind of visualize it with a straight line between them, like so. So the average rate of change is like the slope between the 2 points if there was a straight line there. So if we look at this line goes down if we're looking left to right. And so our average rate of change between A and B would be negative. Negative. And we can say that the average rate of change is negative because f of B, the y value of B, is less than that of A, is less than f of A. So when it went from A to B, the value of the function decreased. So another way of saying it, I'll write it down. Value of function decreased from A to B. Now you don't have to say it like this. Simply saying that the line connecting the 2 points on the graph is decreasing is enough, because it means that it has a negative slope. So I'm going to write that right here. down graph between the points. I apologize for my bad handwriting, I know. But yeah, so that completes part E here. So you can either use the function value reasoning, you can talk about how the value of the function decreased from A to B, you can talk about a line on the graph connecting the two dots, having a negative slope. All of those reasonings would work as an explanation for why it is negative in part E. So moving on to part F is, okay, I realize I need to see the graph in here too. There we go. Is f of d minus f of b over d minus b positive, negative, or zero? So if we're looking at this here, it kind of looks like the slope equation, and that's because it is. And we are going from b to d in this one, and I know that because in the slope equation, it always goes final minus initial, right? So here, I'm changing over to green. And if we look up here on the graph, we're doing f of d, so that is r, minus f of b, which is also r. Ooh, look at that. Okay, so let's plug that in. So f of d is r, right? So we have that in here. F of b, the y value at b, is also r. So we're going to plug r in for both of those values because each one of those is equal to r. And on the bottom, we have d minus b. And we can see on the graph that they are at the same y value, right? And the slope between them, if I draw a straight line through them, oops, that was bad. Let me redo that line. If I draw a straight line between them, we can see that the slope of that line is 0. And that is one valid argument for that slope equation being equal to 0. But we can also, when we plug in r like we did here, we can say r minus r is 0 over d minus b. 0 divided by anything is still 0. And so we can say that b and d have the same y value. And the expression is an average rate of change. That's what that equation is. All right. So moving on to part G, I'm going to switch over to red. We haven't been red in a while. So if we look up at the graph, we can still see it a little bit at the top of our screen. We have r minus s over c minus d, and we're determining whether it's positive, negative, or 0 again. And so that is also kind of an average rate of change formula, right? Because if we notice, we have points on the graph up here. If we look at c, it's c comma s, and we have d comma r. Now if we notice, we look back at this equation, and it originally kind of looks like a slope equation. However, we have final minus initial on both the top and the bottom. So you would think that c and r would be together, but looking at the graph, we know they're not. So we can't think about this one in slope because it's not actually a slope equation. However, we can compare the values of r and s and that of c and d. So we know looking at our graph that if we look at the y values, r, let me get my pen here. I thought I had a pen. There we go. R is bigger than S. And then we also know that D is bigger than C. That needs to be a C. There we go. So if we look at R minus S, that's a bigger number minus a small number, right? Since R is greater than S. And if we're just thinking about positive numbers, we can think of it like big minus the small. On the top, if I'm rewriting r minus s over c minus d in terms of the bigger and smaller values. So c is smaller, so we have a smaller positive number minus a bigger positive number, right? So if we have 4 minus 2, we're going to end up with a positive number. And if we have like 2 minus 4, we're going to end up with a negative number. So 2 and 4 are just my examples for bigger and smaller positive numbers. But if we have a positive divided by a negative, we're going to end up with a negative overall. And so, yeah, noticing that one of those values is bigger than the other and just doing the reasoning based on the graph, that's what your professor is looking for here. So now looking at H, find the slope of a line that passes through the graph of f at D and E. At x equals D and x equals E. So I'm going to go ahead and clear off our graph up at the top of just the other things that were already on there, just to make it easy to see. And we're going to work in blue. Okay, so the graph is going to pass through D and E, right? And so the point of D has a y value of r, and the point of E has a y value of p, right? And so we're going from D to E. Yeah, because it's passing through the graph at both of those points, which means it has to look like this, right? So we can use the average rate of change formula between D and E to find the slope of that line. So if we're using average rate of change, we have final minus initial on both the top and the bottom. So we'll have our y values first. So our final y value is p, and then our initial y value is r, and then our final x value is e, and our initial x value is d. So our expression is p minus r over e minus d, and that's what your solution is for part H. All right, and I believe that concludes the part 4 of the exam review. Good luck on your exam, guys.